Hello friends, welcome to my YouTube channel of Debneel's Mathematics Desk. Finally, we have reached the last part of rational numbers for class 8 happily. So it's been a long chapter, but not hard things, right? Easy things we have learned till now. But this is a very important part 5 that we are going to do today. So observe everything carefully first of all. And before beginning my video, a huge thanks to all of you guys who have supported my channel so well till now. Keep supporting my channel and motivating me if you found my videos and all the easy and medium every type of means, sums and formulas very informative and helpful, and everything if it was clear to you, then leave a like and share and subscribe my channel. It motivates me to make better videos for you on this long and interesting chapters. Okay, so part 5 of this chapter. So obviously this is the only chapter which has been is completed been part means 5 parts by me for any video. So let's see this part 5 what it has for us. So I told you that part 5 will be a surprise. So yes, now it's time to reveal the surprise. So we will be solving number lines and insertion of rational numbers between two rational numbers. I don't think you understood it properly. So first of all, coming to number lines. So linear inequations you all know. So obviously you know number line. So number line is a line, okay, straight line. Something like this. My drawing, I know it's horrible. It extends in both axes as well. In the center of this line, we have 0. In the right hand side, it keeps going in the positive direction. So positive numbers are written in the right hand side. So I can consider 1 here. Then 2, then 3, and you can just keep writing as many numbers as you can. The size of the number line you have drawn. Always see the question what is the maximum limit on either side. The numbers have been asked to you. Draw the number line according to that. Don't draw a number line with 40 at the end of the positive direction to make your life hell. Don't do that. And in the left hand side of 0, the negative values or minus values they are written. So like this. Yes. So pens are used to means right. My pen is rubbing my writing. Wow, what a friendly enemy. You should be given an award, right? So this is in the negative direction. This is the negative side. I like this. So here, what you know. So suppose I am giving you a question. 1/3. Find this number on the number line. Now you will be scratching your head. What is that now? You have given number. So what is 1/3? So see, 0 means what? 0/3. Then 1/3 is there. Then 2/3 is there. Then comes 3/3. So 3/3 is 1. So 0. Then 0/3 is 0. Then suppose this is another smaller division. 1/3. Then 2/3. And 3/3 will be 1, right? So 1. So 1/3 is which one? This. So you have to just mark it like this. That's how you have to do marking, okay? So let's see a sum on number lines, how it can be done. First of all, I am taking a number line with a beautiful red pen. Let's see. So I am taking this on this side, the number line. Like this. Then 0, 1, 2, 3, 4, and here on the negative direction, -1, -2, -3, -4, it will be like this. So this is our number line which will help us to do the sums. Now let's see the question. So they have asked to level means mark a few numbers on the number line. Mark what? 2/3, comma -8/3, comma 7 by 3. Then minus 2 by 3, comma, minus 2 on the number line. Okay. So here, so what you have to know, you have to just follow a simple thing here. See, you have to keep the denominators same of each of the numbers. You can do that, a little more means helpful for you. So minus 2 is what? So we have to keep the denominator 3. So write this minus 2 equal to x by 3, suppose, or x equal to minus 6, right? Therefore minus 2 equal to minus 6 by 3. So let this minus 2 be minus 6 by 3. Now see, you have to see all the denominators are 3. So here I have 0. That is 0 by 3. So after 0 by 3, what will come? 1 by 3. Okay. So let me give a bracket here. Suppose this is 1 by 3. Then after 1 by 3, 2 by 3 will come. This is 2 by 3. After 2 by 3, 3 by 3 will come, which is 1. Already it is given. Yeah. Then after 3 by 3, 4 by 3 will come, which is 1 whole 1 by 3. Okay. Then 5 by 3 will come, which is 1 whole 2 by 3. Then again 6 by 3 will come, which is 2. Already given. So just like that. Now I hope you can understand. So I am just directly writing it. 7 by 3, 8 by 3, then 9 by 3, 3. 10 by 3, 11 by 3, 12 by 3, 4. A negative hand. This is 0 by 3. Okay. Then in a negative direction, it will be minus 1 by 3. First one. Why are you rubbing, man? Why are you rubbing? It should be. Why I don't know. My pen is like an eraser. Crazy. See? That's weird. Did I buy eraser by mistake? Do you want to tell me that? No, I didn't think so. Then I will kill the shopkeeper. Looks like what is happening, I don't know, guys, but my pen is not supporting me. Looks like the way I tell you at the beginning that support my channel, I have to tell this pen as well, support my channel. Okay, so nothing to do. So 0 by 3. Then in the negative direction, it will be minus 1 by 3, the first one. Then comes minus 2 by 3. Then minus 3 by 3 is 1, minus 1. Already there. Then minus 4 by 3 is minus 1 whole 1 by 3. Okay. Then minus 1 whole 2 by 3. Then minus 1 whole 3 by 3 means minus 1 plus 1, minus 1 minus 1, right? Minus 1 whole 3 by 3 means what? Minus 6 by 3. This is minus 2. Yes. So then here I have after minus 2, then minus 7 by 3, minus 8 by 3, minus 9 by 3, it is minus 3. Then minus 10 by 3, minus 11 by 3, and minus 12 by 3 is minus 4. Okay, now we have it. So let's see the numbers. 2 by 3, 0 by 3, then 1 by 3, then 2 by 3. So this is our first number. So 2 by 3 here. 2 by 3, let it be A. Then what is it? Minus 8 by 3. Okay. Minus 8 by 3. That is what? Minus 3, minus 2 whole 3 by, what is it? Minus 8 by 3. 3 into 2, no. Minus 2 whole 2 by 3. Right. Minus 8 by 3 is minus 2 whole 2 by 3. So minus 2. No, suppose this is 0 by 3. Minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 1. Minus 4 by 3, minus 5 by 3, minus 6 by 3, minus 2. Minus 7 by 3, minus 8 by 3. Minus 8 by 3. Here. Got it. B suppose. Then 7 by 3. 7 by 3 is 2 whole 1 by 3. So 2 then 1 by 3 here 1 by 3. So this number 7 by 3. C. And then minus 2 by 3. So 0 minus 1 by 3 minus 2 by 3. This number. This one. Minus 2 by 3. D. And then minus 2 you already got minus 6 by 3. So this is minus 2 directly you can see. So what to do? Minus 2. E. So that is how you do number lines. So according to the denominator your divisions will be there. So 0 is there, then 1 by 3, 2 by 3, then 3 by 3 is coming. That is 1. So put a 1. So 2 divisions in between. Right. That's how in the positive direction, in the negative direction, you draw the numbers. And then you can just locate them, right? 2 by 3. So from 0, then 1 by 3, then 2 by 3, then 3 by 3 is coming. Why the hell did this get rubbed? Yes. So, okay, this will be looking much more clear. So 1 by 3, 0 by 3, then 1 by 3, 2 by 3, then 3 by 3, 1. 4 by 3, 5 by 3, then 6 by 3, 2. So you have 2 by 3, A. Then minus 8 by 3. It is minus 2 whole 2 by 3. Minus 2, then minus 2, 1 by 3, minus 2, 2 by 3. Minus 8 by 3. 7 by 3, 2 whole 1 by 3. 2, then 1 by 3. So 7 by 3. Then minus 2 by 3. 0, minus 1 by 3, minus 2 by 3 already. And minus 2 directly you can see, just plot it. Finished. Number lines are easy, right? Draw the number line. Make the denominators common. You should see that the denominators are common. Okay. Remember when you did means number lines for natural and whole numbers. Remember one thing. Their denominator was 1 almost. Always. The denominator of every natural whole number, everything it is 1. So their denominators are already common. So we have to see that the denominators are common. Then only we can frame regular divisions like this, right? That's the main principle. So done with the number lines. Easy, right? Easy stuff. It's nice. If you drawing a number line is nothing, then see the number of means denominator, then 3. So 3 units from 0, then 1, 2, 3. 0 by 3, 1 by 3, 1 unit, 2 by 3, 1 unit, then 3 by 3, 1 is coming, another unit. Just like that, you have to keep doing in the positive and negative direction and plot the numbers accordingly. It's easy. Now, inserting rational numbers between two rational numbers. So, there are two methods. Suppose there are two rational numbers a by b, a comma b. I tell you, insert one rational number between a and b. What you can do now, that other rational number will be a plus b by 2. What is this? This is, I am writing r number, okay, rational number is, r number is rational number between a comma b. That's how you can do. This is the method of inserting one rational number between a and b. Now if you are told to insert two rational numbers between a and b, then already you got one, right? So then what are the like numbers then? So this is a, then a plus b by 2, and then b, right? Because a plus b by 2 is the number between a and b. Now to get the next rational number, suppose you have to insert another rational number between a and b. What you can do, another number, another r number, rational number equal to a plus b by 2 divided by 2. Another rational number. Okay, not like that. A plus. So means see, if you have 1 comma 3, then you can add another number 1 plus 3 by 2. It will be equal to 2. then 1 comma 2 comma 3. Again to add another rational number you can do 1 comma 1 plus 2 by 2, then again 2, again 3. Means you can keep going. Then this will be what? Equal to 1 comma 3 by 2 comma 2 comma 3. Again if you are told to insert another number, then you can do equal to 1 comma 3 by 2 comma 3 by 2 plus 2 divided by 2 comma 2 comma 3. Right, 1 comma 3 by 2, then the sum of these numbers by 2, then again 2 is also there, and then 3. So you can keep expanding. Okay, so this is one method you can apply. Another method is also there, which is like this. Suppose I tell you insert, my this pen is horrible. I tell you suppose insert two rational numbers R number between 2 comma 5, suppose 2 comma 3. So you have been told that insert two rational numbers. So what you can do, see this is 2 by 1, this is 3 by 1. So you have to multiply the numerator and denominator of both of these numbers by the number greater than the number of numbers required to insert between these two rational numbers. I am explaining you. I am trying to explain. See, here I have 2 by 1 comma 3 by 1. I have been told to insert two rational numbers between them. So I will multiply both of these numbers numerator and denominator by 3. One greater than the required rational numbers to be inserted. This will be equal to 2 by 1 into 3 by into 3 comma 3 into 1 by what is this now? Sorry, 3 into 3 by 1 into 3. This will be what? 6 by 3 comma 9 by 3. Now you see between these two numbers you have 7 by 3 comma 8 by 3, right? So these are the two rational numbers between 2 by 1 and 3 by 1. So number of rational numbers you have been told to insert, multiply the numerator and denominator of the numbers you have been told to by 1, that means 1 greater than the required rational numbers to be inserted. This is the method. So we will practically see this in the sums. Okay, so very good methods these are. I will advise to use this method, but this was also quite easy. It's like a little bit of a puzzle type, so you can do that. It's a little bit complicated actually, I think. For me it can be easy for you. Let's see. I'm keeping this rough work. Okay, no need. You have understood, right, how to do. First of all, coming to the first one, my pen doesn't want to do any work. Lazy people. Insert one. I'm okay. So rational number. I'm just giving a heading. I will use this. This is I am writing this as R number. Okay, an R number between. Now what is that? 3.5 comma 5. I told you one rational number between A and B equal to A plus B by 2. For R number equal to 3.5 plus 5 by 2 equal to 8.5 by 2. 8.5 by 2 is equal to 4.25. So that is the required rational number. Therefore numbers are now, what are the numbers now? See, equal to 3.5 comma 4.25 comma 5. Okay, easy. It's like doing the what is that called? Arithmetic mean. When you are told to insert one rational number between two numbers, that rational number to be inserted equal to the sum of the numbers by 2. And you get the answer. C 4.25 is the number now between these two. Okay, very easy stuff. Let's see the next one. Slowly the difficulty will keep increasing. Sorry guys, I'm not well actually. Having medicine since 15 days but still not well. What would I don't know. Give me some advice if you can in the comments. Now, insert two rational. Oh, why am I doing that? Why am I working hard? I have already written in the heading. Two are numbers, rational numbers between 6 commas. Now, so now see. So one R number. Already we know one R number can be A plus B by 2. So equal to 6 plus 7 by 2. 13 by 2 it is 6.5. Okay. Therefore, new numbers. Now what are the numbers? Let's equal to 6, then 6.5, then 7. So one number is inserted. What about the next? Now I can do second R number equal to, I can do the sum of these two by 2. 6 plus 6.5 by 2. Equal to 13.5 by 2, which is equal to 6.75. Yeah. Therefore, new numbers. Now what are the numbers then? 6, then I have 6.5, then I got what? 6 plus 6.5 by 2, which is 6.75, and at the end I have 7. Finish. See, between 6 and 7 we have two rational numbers now, 6.5 and 6.75. That's the answer of this question, 6.5 and 6.75. Understood? First rational number is sum of the rational numbers by 2. This one. This is the rational number between 6 and 7. One rational number. Another rational number is the sum of these two terms by 2. Go to 6.75. So now what are the new numbers? 6, then 6.5, then this one 6 plus 6.5 by 2, 6.75, and then finally 7. So we see that between 6 and 7 we have 6.5 and 6.75 as rational numbers to be inserted. Two rational numbers gone. Let's check out the next one. It's going easy, right? Means you can use this process in any sum, but there is a but. Suppose when you are told to insert 7, 8 rational numbers between any two rational numbers, then this method will be a bit means hard work for you. What you can do is then use that method. How many rational numbers are given? Multiply the numerator and denominator of the given rational numbers by 1 greater than the required rational numbers to be inserted. So this statement looks like a horrible one, I know, so we will practically see that. So here you go. Now see, this is where I means get angry. I told here you go and my pen is telling me I don't want to go. My friend red pen will send me. Insert 3 rational numbers between 3 by 5, comma 2 by 3. Now, to use that method of multiply a numerator and denominator by one greater than the required rational numbers to be inserted, you have to see if the given rational numbers denominators are same or what. If not, you have to make them same. So 3 by 5 is what? Equal to make the denominator common, right? So equal to 3 into 3 by 5 into 3 equal to 9 by 15. And 2 by 3 is what? Equal to 2 into 5 by 3 into 5. So 2 into 5 is 10, equal to 10 by 15. Now see, we have the denominators common. 9 by 15, 10 by 15. Now, to insert three rational numbers between these two, we have to multiply the numerators and denominators by 4. One more than the required rational numbers to be inserted. So then, therefore, 9 by 15 equal to 9 into 4 by 15 into 4 equal to 36 by 60, and 10 by 15 equal to 10 into 4 by 15 into 4 equal to 40 by 60. Now see, between, therefore, between, now my red pen wants to sleep. Everyone goes sleeping and now I have to write using hands. They are telling me like that. Sorry, can't do that. For three numbers, now see this, the magic. Three numbers between 36 by 60, 40 by 60 equal to. Now see, denominators are same. Now you tell me how many numbers are there between 36 and 40. 37, 38, 39. Three numbers, that is 37 by 60, 38 by 60, 39 by 60. Yes. So it's going well. Now what do you have to do? I'm writing here. You have to simplify these numbers. Therefore, now 36 by 60 is what? 3 by 5. You can see the back calculation as well here. Okay. Therefore, 3 are numbers between 3 by 5, 2 by 3. What are they? One we got 37 by 60, it can't be simplified. 38 by 60. So you can divide by 2 the numerator and denominator, you will get 19 by 30. And then 39 by 60, can divide the denominator and numerator by 3. You will get 13 by 20. And that's the answer of this question. So you understood the process. First we made the denominators of the rational numbers given same. Then we multiplied the numerators and denominators by one more than the required rational numbers to be inserted. 1 more than 3 is 4. I multiplied the numerators and denominators by 4. I got 36 by 60 and 40 by 60. Now, three numbers between 36 and by 60 and 40 by 60. That 37 by 60, 38 by 60, 39 by 60, right? Now, 36 by 60 is 3 by 5 and 40 by 60 is 2 by 3. Then three numbers between 3 by 5, 2 by 3 is what? 37 by 60. Then 38 by 60 if you simplify by dividing the numerators and denominators by 2, you get 19 by 30. Then 39 by 60 is what? Divide the numerator and denominator by 3, you get 13 by 20. Those are the required numbers. And see, three numbers. So we just exactly got three, right? No means choice, exact figures. 36, between 36 and 40, only three numbers are there. So that is the main significance of this process, which allows you to select the accurate numbers between the given rational numbers. However, how many they are required. Just like that. Easy, right? Denominator same. Multiply the numerator and denominator, the given rational numbers, by one more than the required rational numbers to be inserted. Finished. You will get the answer. Let's see the next one. Okay, so I have come to the last question for today. This part 5, I am telling you, it's not about solving many sums, it's about understanding the process. Seeing which process can make you solve it much faster and much more accurately. You means I will tell you, never do that process of means for three rational numbers. A plus b by 2, then a plus b by 2 by 2. It will become a means mathematical puzzle, and you will be means roaming in the puzzle for infinity. It's not good. It means it takes much time, and mistakes can come anytime. Means you can get means lost. Where am I? Which number I should means add and divide by 2 to get the next number. It's confusing. For less numbers required to be inserted, you can use that process. But for suppose 6 rational numbers between a comma b, 7 rational numbers between a comma b, multiply the numerators and denominators by one more than the required rational numbers. If the denominators of the given rational numbers are same. Okay, so let's get to the last sum for today. 5 sums, but they were good. Now see this. Insert. This pen is horrible. Any other person I can use to complete my video? Let me just see. This pen might help me. Insert 7. Yes, you heard it right. 7 rational numbers between 2 comma 3. Okay, don't get scared. It's not natural numbers. Then it would have been impossible. It is rational numbers. See, 2 is what? 2 by 1. 3 is what happened to my pen? Going crazy, huh? 2 and 3 is 3 by 1. So the denominators are same. So now see, we have been told to insert 7 rational numbers between them. So I will multiply each of the numerator and denominator of each of these fractions by 8. One more than the required rational numbers to be inserted. Then what does it become? 2 by 1 equal to 2 into what happened to my pen now? This is not good. Stop making fun of me, my pen. 2 by 1 is what? 2 into... Okay, this is not fair. 2 by 1 is 2 into 8 by 1 into 8. Then one more than the required rational numbers to be inserted. So 16 by 2. Yes. And then 3 by 1 is equal to 3 into 8 by 1 into... Oh, this is 16 by 8, sorry. 1 into 8. So this will be 24 by 8. Now see this. So numbers between 16 by 8 comma 24 by 8. What are they? Equal to 17 by 8 and 18 by 8 19 by 8. 7 rational numbers we need. Then 20 by 8. 21 by 8. 22 by 8. 23 by 8. Then what is the 24 by 8? Can't write it between. So excluding 16 by 8 and 24 by 8. See, we have 1, 2, 3, 4, 5, 6, 7 rational numbers between these two. Now, what is 16 by 8? 2. Therefore, let's use red pen. Let's use our finisher, red pen. Therefore, then 7 numbers were there, right? So 7 rational numbers between 16 by 8. It is 2. And 24 by 3, 8, it is 3 equal to 17 by 8 can't be simplified. 18 by 8 can be simplified by dividing denominator and numerator by 2. It will be 9 by 4. Then 19 by 8 can't be simplified. 20 by 8 it can be by dividing the numerator and denominator by 4. 20 by 4 it is 5. 8 by 4 it is 2. 21 by 8 can't be simplified. 22 by 8 divide each of them by 2. So 11 by 4 and 23 by 8 can't be simplified. This question, which could have taken you huge time if you had done that a plus b by 2, a plus b by 2 by 2, then again keep going until 7 numbers are there. That could have taken you, I have seen this, how much time it can take. I have done a calculation. It will take you 15 minutes approximately. And this one, I think, if you see the starting of my sum and ending of my sum, it took 4 to 5 minutes approximately. See the saving of time and see how accurate this process is. What is there in it? Denominators of the numbers are same. Okay, 2 is 2 by 1, 3 is 3 by 1. Then I have been told to insert 7 rational numbers. So I will multiply the denominator and numerator of each of these fractions by 8. One more than the required rational numbers to be inserted. Doing that, I get 16 by 8 and 24 by 8. Now, you tell me, what are the numbers between 16 and 24? 17, 18, 19, 20, 21, 22, 23. 7 rational, 7 numbers are there, right? Then 17 by 8, 18 by 8, 19 by 8, 20 by 8, 21 by 8, 22 by 8, 23 by 8. Then 7 rational numbers obviously between 2, 3 are what? 16 by 8 is 2 and 24 by 8 is 3. 17 by 8, then 18 by 8 simplifying 9 by 4. 19 by 8 simplifying 19 by 8 only, nothing else. 20 by 8 if you simplify, you get 5 by 2. It's because I'm not feeling well actually. 21 by 8. 22 by 8 if you simplify 11 by 4. And 23 by 8 if you simplify 23 by 8 only. See, you are not able to get means more than 7 rational numbers between these two if you use this process. Means these are the accurate numbers. Isn't that remarkable? You means teacher is means forced to give you full marks because no other number can be done. Yes, you could have means you can multiply the numerator and denominator of the rational numbers given by any number if the denominators are same. Okay, then also you can get 7 rational numbers and you can simplify, but there you have the chance of choice. And I means think personally that if you are means selecting some numbers from an ocean, then those selections can be means not good to someone's point of view. Okay, so giving the accurate numbers beyond which no numbers can be there, just like this between 16 and 24 only 7 numbers, so those 7 only, so you are bound to give full marks to the student if he or she does this. So actually I recommend that you should use this process more frequently. See, you can also insert, if you are told to insert one rational number between 2 and 3, you can multiply the denominator and numerator by 2. Okay, then you get 4 by 2 and 6 by 2. The number between 4 by 2 and 6 by 2 is 5 by 2. So here there you get a rational number as well. So every sum like this can be solved using this process. But the only thing is that for smaller numbers, that process can be used, because average and arithmetic mean is quite basic things, right? So you can use that process only if you are told to insert one or two rational numbers between any two rational numbers. But greater than 2, use this process. Must. This will help you solve the sum by 1/3 time of the time it would have taken to solve using that arithmetic mean method. So this finishes this huge chapter of rational numbers for class 8. So many things we learned: introductory concepts of rational numbers, the operations on rational numbers, which are addition, subtraction, multiplication, and division. And today we learned number lines and how to insert rational numbers between two rational numbers using the arithmetic mean or average method, and multiplying the denominator and numerator of the rational numbers if they are same, the denominators, by one more than the required rational numbers to be inserted, and then getting the accurate answers. So this is all from rational numbers class 8 and part 5 as well. So then, if you found my video on this part 5 of this huge chapter very interesting and helpful, then leave a like and share and subscribe my channel. It motivates me to make better videos for you all on these interesting topics. And get ready, because in the next video for class 8 a new chapter is coming. Finally, we have got out of the clutches of rational numbers. So let's see what variety the new chapter will have. Not now, in the beginning of the next video you will see that. Till then, with a lot of love from my side to all my little brothers and sisters, take care and goodbye. And yes, the year is about to end. Christmas and New Year are by the door. So let's welcome them very soon. So happy celebrations. Take care and goodbye.